Every climate model on Earth had the same salt error baked in, meaning the Atlantic's biggest current is slowing faster than anyone predicted. Last month, 4 monitoring stations confirmed a 2-decade slowdown. Here's what that current actually does, because once you see how it works, everything changes. The Atlantic circulation moves warm tropical water north toward Europe. Warm, salty water flows at the surface like a massive ocean conveyor belt. When it hits the cold Arctic, it gets dense and sinks nearly 2 kilometers. That sinking pulls the whole system forward, like a pump that never stops. It's why you can walk through London in January without a heavy coat. Here's where the salt error hits, because Greenland's meltwater dilutes that salty engine. Models assumed salt levels would hold, meaning they missed the slowdown by 51%. University of Miami researchers tracked 4 Atlantic sites for 2 decades. The current weakened at every single station they measured. So the question isn't whether it's slowing, it's what happens to us when it stops. Here's the problem: every major climate model had the same hidden flaw. They were all running too much salt in the North Atlantic simulations, meaning the simulated ocean was denser than the one under your feet. Denser water sinks faster, so the models showed a current that wouldn't quit. When Utrecht researchers corrected the salt bias, the forecast changed completely. The corrected models told a different story: 51% AMOC collapse by 2100. Every projection you've trusted until last month ran on flawed physics. But models are just math. So what does the actual ocean say? 4 separate monitoring arrays have measured the actual Atlantic current for 20 years. The Rapid array stretches from Florida to the Canary Islands at 26 degrees north. And what the instruments show matches those corrected models: a steady decline. Last month, the University of Miami team confirmed it across all 4 sites. This isn't a model glitch. You're looking at 20 years of measured ocean data. The question now isn't whether it's slowing, it's how fast the slowdown accelerates. So what does a 51% slowdown actually do to us? Northern Europe loses its ocean heating system while the rest of Earth keeps warming. West African monsoons shift south, meaning 200 million people lose predictable rain. Here's the part nobody sees coming: the US East Coast gets accelerated sea level rise. When AMOC slows, it stops pulling water away from American shores, so the ocean stacks up. North Atlantic cod populations collapse next because they follow that warm conveyor current. European wheat yields drop 15% in every model projection past 2070. Now here's where it stops being a chart and becomes somebody's Tuesday morning. A fishing family in Bergen, Norway, 3 generations working the same boat since 1960. Their catch dropped 40% in the last 8 years, and they cannot explain it. A farmer outside Dakar watches his millet die for the 3rd consecutive season. His grandfather never saw a failed monsoon. He has seen 3 in 5 years. A family in Norfolk, Virginia stacks sandbags every spring where water never reached before. These are not projections. This is the current that decides their lives slowing down right now. Here's what nobody caught: every major climate model shared the same salt error. They underestimated how much fresh meltwater dilutes the North Atlantic sinking zone, meaning the real slowdown is far worse than any published projection showed. Utrecht corrected that one variable last month, and the answer changed to 51% collapse by 2100. And here's what seals it: 4 separate monitoring stations across the Atlantic show the same weakening. A full 2 decades of measured decline at depth, not modeled guesses anymore. So the models were being optimistic, and the ocean was already proving them right. Which means you and I are watching a system lose strength in real time. The Gulf Stream warmth that keeps Northern Europe 10 degrees warmer than it should be. That warmth depends entirely on this conveyor belt running at full capacity. And now we have 20 years of hard data showing it hasn't been. Remember that dense, salty water sinking in the North Atlantic we started with? Same ocean and same current. But now you see what's weakening underneath the surface. The next decade of measurements will tell us whether this is a slowdown or a shutdown.